Hey everyone! In this video, we're going to be taking a look at how to use the chain rule with some more exponential functions. We've already looked at how to use the chain rule when we have base e, but now we're going to take a look at how to use the chain rule when we have any other base. So first of all, let's just remind ourselves of the chain rule with base e. So if we have a function, y is equal to e to some power u of x, with the chain rule, we end up with the derivative is our original function, so this is just repeated, times the derivative of our exponent. So I'm going to use this to help us find the derivative when we have other bases. So let's say I have some other equation. Let's say we have y is equal to a to the x power. So here a can be any number, and we want to be able to find the derivative of this. So I already have established a rule for finding the derivative when we have base e. So what I'm going to do is I'm going to take this equation and I want to rewrite it as something that's base e. So to do that, we're going to need some properties of logarithms. So just to remind you, we have a couple properties with base e. For example, if I have the natural log of e to x, we know that this just simplifies to x. And furthermore, if we have e raised to the natural log of x, this also simplifies to x. So we can use that to rewrite this equation. So this is equal to e raised to the natural log of a to the x power. The e in the natural log will simplify. Now that I have it rewritten like this, I can actually take this exponent and I can bring that down out front. So that's our power rule for logarithms. So going one step further here, we end up with e raised to the x times the natural log of a power. From here, now I have something that's base e. So if I want to find the derivative of this, so the derivative, it's going to be my original exponential, so this just gets repeated. And then we're going to multiply this by the derivative of the exponent. The natural log of a, remember a is just a constant. So we have a constant times x. The derivative of this is just that constant. So it's just the natural log of a. Now let's go one step further, where instead of writing this as e to the x times the natural log of a power, let's go back to what this started as. So remember, this whole thing started as just a to the x. So the derivative is equal to a to the x power times the natural log of a. And this is our derivative for any base. So let's use this in a couple examples. So my first one, very basic. I have y is equal to 2 to the x. So let me just rewrite our rule here. So y prime is going to be equal to a to the x times the natural log of a. So here, a, my base, is equal to 2. So the derivative of this equation, so we repeat the original and times the natural log of the base. That's it. That's our derivative. Now, in the second equation, a little bit more complicated, I have y is equal to 3 to the x squared plus 1 power. So in this case, I actually need to use the chain rule. So the chain rule, we're going to take the derivative of the outside function, and we'll multiply that by the derivative of the inside function. So first off, just to rewrite this, let's let u equal our exponent. So then that gives me, I can rewrite my original equation as y is equal to 3 to the u power. So the derivative of the outside, the derivative of y with respect to u, so the y is equal to 3 to the u power, I'm going to use my new rule. So it's the original times the natural log of the base. And then, just like we have done in the past, let's resubstitute so we can get x's in there instead of the u's. So the derivative of the outside, we end up with 3 to the x squared plus 1 power times the natural log of 3. And then we need the derivative of the inside. So this is the derivative of our exponent. So du over dx. And following the power rule, we just end up with 2x. So for this second example, our derivative is going to be the derivative of the outside times the derivative of the inside. So what we end up with, so y prime is equal to 3 to the x squared plus 1 power times the natural log of 3 times 2x. And if we wanted to, we could rearrange this and rewrite it. So maybe I'll write this as y prime is equal to 2x times 3 to the x squared plus 1 power times the natural log of 3.